Hello, welcome to Star Cells and God. I'm Jeff Zweerink. Today I'm joined with Dr. Fuz Rana, and we're going to be talking about what we learn if we look out and find no life, and what do motherless mice mean to us. Well, Fuz, it's good to have you here today. Got to say, I'm intrigued to know what motherless mice has to tell us and why in the world we're doing this research. But I'll just go ahead and throw it to you and let you open us up.
Yeah. Okay. Well, to kind of set the stage to address your question, things have changed quite a bit in my lifetime.
Okay.
And for example, how I get news, right? When I was growing up, and even as a young adult, the way you got news in the morning was with the newspaper, right?
Yes.
So I can remember as a little kid, I usually was the first one up, and it was my job to go to the end of the driveway and get the newspaper and bring it back. And so whether it was rain or shine, hot or cold, no matter how deep the snow was, it was my job to make that trek
Right.
to the end of the driveway. And of course, the benefit was I got first crack at the newspaper.
Oh, you did? I was wondering whether it was like you got to get it and it was not touched until somebody else had it. No, so
Yeah.
what'd you read when you opened up the newspaper?
Sports and the comics. And then
in that order?
Yeah, and as I got older, I would look at the news and sometimes the editorials.
Gotcha.
Because I was told in high school that an intelligent person reads the editorials.
Okay.
So I wanted to be an intelligent person. And even when my wife and I bought our first home, part of that package was getting a subscription to the Cincinnati Enquirer.
Right. Yeah.
So, and now, of course, today it's all my news is from different websites.
Mm-hmm.
And so the first thing I do when I get up in the morning isn't go to the end of the driveway, but it's to open up my smartphone or my iPad and visit different sites. And I know that a news item is really important if it appears at different sites.
Yes. Okay.
Yeah. So the more I see those headlines, the more important I know that particular event is.
Mm-hmm.
And about a month ago, there were headlines all over the place about scientists creating mice that had two fathers and no mother.
Okay.
And so, that of course raises all kinds of questions, like we were talking off air about why on earth would these scientists do this? What's the motivation? And oftentimes our first response is this some kind of research that's designed to support a political agenda, right?
Okay.
Or, is it possible for two gay men, let's say, now to have children where each of them are contributing to the genetic makeup of the child, right? Is that the motivation?
Okay. Yeah. No, I get the connection
Yeah.
there.
So
Yeah.
is that when I was telling my wife about this, that was exactly where she went.
Gotcha.
Right. Or, in this work, of course, raises questions. Why would the scientists do this? What did they do? And really, should they do this type of work? Right. And that question is best summated with a single question: should we play God? And it's not just Christians that ask that question; it's secular people too, almost in an identical way. And so, it really is important for us as Christians to engage advances that are happening in biotechnology thoughtfully and responsibly. This is not a one-off. There are, these types of headlines that are basically almost a weekly occurrence, maybe even at times a daily occurrence. And it just raises, again, all kinds of questions. And
well, this is, it was probably 20 plus years ago now, because I think it was even before I started working here where we started cloning sheep. It sounds like this is taking that, it's kind of it's in that line of research and just kind of upping the ante, if you will.
Yes, exactly. It is in that vein. Exactly. And, the problem is, of course, that as Christians, we have a particular worldview that we think is an important worldview that contributes to our world in a positive way. So we want to make sure that we understand the technology, we understand the ethical issues, even the theological issues, and that out of that understanding, we're helping our society to have important conversations determining, should we develop a technology, and if we do, how should we deploy it? But there's also, I think, another reason that we really need to make sure we understand these emerging biotechnologies, and that is oftentimes Christians, whether rightly or wrongly, get the perception that we stand in the way of science, We stand in the way of
Hmm.
technological advance for theological reasons,
Okay, right.
and by doing so, we prevent insights that from developing or technologies from developing that really could improve the quality of people's lives. And just as an example, about a month ago, there was an article, an op-ed piece in this from a website called Futurism. And the title of the article is Scientists Who Gene Hacked Human Babies Says Ethics Are Holding Back Scientific Progress.
Hmm.
And I can't tell you how often I encounter that mindset, particularly among secular scientists, particularly those working in the
Hmm.
life sciences and in biotechnology, where they just see ethics and even worse theology really holding back scientific progress. And so for those people, they don't even see Christianity as false. They see Christianity as harmful.
Detrimental, yeah.
Yeah. And so what we want to do is make sure that we are engaging technological advances well, so and recognizing what the benefits are, but also where the shortcomings are,
Hmm.
so that people understand that not only is Christianity true, but it's actually good for the world. And part of that comes from really people respecting the fact that we've understood the technology and how it could be used in a positive way, and that we really are representing a voice
Hmm.
for protection, a voice of protection, particularly for marginalized people that could be exploited by these biotechnologies.
Yeah, it's just interesting because a few nights ago I was having a discussion in a men's group, and well, so the particular question I raise is, there are times where we have these songs that we're singing in church where it confuses the Trinity, or the
Mm.
one has a lyric where it says, "Our God is risen from the grave." And I'm thinking, okay, implications of that. Does that mean God can die? And so
Yeah.
I'm kind of thinking along those lines, and I raise those, and it's like there's kind of this. It was almost a little bit about, oh, you're just being overly picky,
Yeah.
and the thought that occurs to me is like I live in a world where people pick at stuff like that. That's a pejorative way of saying, where people take wrong thoughts and say, well, if this is
Mm.
what it means, do you really mean that? And so I've learned to be more careful,
Mm.
because if I don't, I'm in a bad. But it's a lot more work to do that. This strikes me as in that class of, you kind of look at that and say, okay, this seems like a bad idea. I'm just going to, I think it's a bad idea, or it's
Mm.
clearly it's unethical. But if I get what you're saying, and I'll let you develop your thoughts more after this, but that requires more work for Christians to be
Mm.
able to engage this well. And being as though there's a lot of other things I'm trying to do to live a Christian life, why do I
Right.
need to engage this?
Yeah, yeah. That's a great point, and actually, you're spot on because it does take a lot of work to understand the technology, to understand genuinely what the ethical issues are, and then to properly engage.
Hmm.
But it's well worth it because I think it really it it's critical because whether we are doing that or not, the technology is going to develop and it's
Yeah.
going to be deployed. So, do we want to help shape how that's going to be developed and deployed? But also, we want to make sure that people understand the positive aspects of Christianity, and that when
Hmm.
we're saying no for good reason.
Right. Well,
And
and it seems like there's another benefit there too of it. If Christians understand the technology, they understand the limitations and weaknesses and strengths and benefits, which will also help us use the technology well instead
mm,
of just being sucked into
right.
whatever society is saying about
Yes.
it. So,
So yeah,
okay.
great points, Jeff. Well, I mean, these particular headlines were inspired by a paper published in Cell Stem Cell. So here's a picture of the journal article. Is actually written by a research team from China at the Chinese Academy of Sciences. And Cell Stem Cell, it's an awkward journal title, but it's part of the Cell family of journals. So Cell is a highly respected journal, primarily publishing work in cell biology, but there's variation, or there's other journals that Cell has spawned. One of them is focused exclusively on stem cells.
Okay.
So that's where this work was published. And the reason why these scientists were doing this work was not nefarious by any means. They really were trying to develop a research tool using biotechnology that allows them to understand something called genomic imprinting.
You have
And
to flesh out what that means.
yes, I figured that would be the case, but but this genomic imprinting is a subset of what are known as epigenetic modifications. And so this is a diagram showing what epigenetic modifications are. And what you see here is the DNA double helix that is then depicted wrapping around histone octamers that are then condensing into a chromosome. And the DNA molecule harbors genetic information.
Mm-hmm.
And the genes that are found in DNA are not all expressed at the same time. Some of them are silent. Some of them are expressed constantly. Those are called housekeeping genes. Some are only used or expressed when that particular protein encoded by the gene is needed by the cell. So during the course of the cell cycle, genes are turned on and turned off so that the proteins are produced at the appropriate time they're needed. When they're no longer needed, those proteins are no longer produced. But differential gene expression also controls how cells develop from a zygote into one of the 210 different cell types that are part of the human body. It's through turning on and turning off genes at the appropriate time during the course of development. And
does that all happen within the context of the DNA? So I mean, the picture I've always had, or kind of largely been taught, is that the DNA, you get a DNA map that tells you everything that you need to know about a human. Does the DNA determine how things get turned on and off, or is that an unknown question at this point?
No, it does indirectly.
It does indirectly,
because it's controlling the proteins that are then playing a role in turning on and turning off the genes.
Okay, all right.
So it's all intertwined. But one mechanism for turning off genes is called epigenetic modifications. And so one form of epigenetics would be to decorate the DNA with methyl groups, and that actually will permanently shut down genes that are affected by that methylation.
And so the epigenetics is stuff that would be something external to the DNA itself.
Yes.
Like, if you eat or drink a certain way, that could change the way that the DNA is methylated, that sort of stuff?
Yes, but there are enzymes that are responsible for the methylation that are encoded by the DNA. So you've got
it's a little more complicated picture. Gotcha.
Right. And there's other epigenetic modifications like acetylating the lysine residues of histone octamers, which in effect cause the DNA to more tightly bind to proteins. And when that happens, then the other proteins that need to access the DNA can't.
Right.
So these are different mechanisms. But genomic imprinting involves a specific type of epigenetic modification that happens in sperm cells and egg cells. So when these cells are forming during a process called gametogenesis, there are certain genes in the sperm genome that are shut down.
Okay.
And there are certain genes in the egg genome that are shut down. But these are different genes. And there's about 200 genes in the egg and the sperm genome that are shut down. And the thought is, nobody knows why, but this is critical for proper embryonic development. We know that. And if you don't have proper genetic or genomic imprinting, it actually can lead to disease conditions.
So when I hear imprinting, most of the time I'm thinking of, newborn animals will imprint on their, that it's a bond that's something not genetically driven. Is that the nature of what's being talked about here, or is it something else?
This is at a molecular scale.
Okay.
Yeah, so in other words, you are imprinting the methyl groups onto the sperm genome and the egg genome.
Okay, all right.
Right. And that's shutting down these genes. And nobody knows why, but one model is called the conflict hypothesis, which basically says that there are genes in the sperm genome that, if they were expressed, would cause the embryo to grow too large. Mm-hmm. And there are genes in the egg genome that, if they're expressed, would prevent the embryo from developing to be large enough.
Okay.
And so that this genomic imprinting is offsetting the effects of those two collections of genes to allow for proper embryonic development. Right. So what the researchers were trying to do is to test this idea by creating mice that came from two male parents, So that they would be two sets of sperm genomes, not a sperm genome and an egg genome.
Hmm. Okay,
Right.
so this is trying to understand something really at how
Yeah.
embryology really works
Yes.
at its fundamental or down at early molecular level, not really related
Right.
to how the organisms are going to
Right.
live later.
And the
Okay.
idea would be that you could then use gene editing to delete in one of those sperm genomes the imprinted genes and
Mm,
to see what happens to embryonic development, right?
okay.
So it's now becomes a tool where you can systematically manipulate genes or eliminate them and see what the effect is.
So is the reason to use two male? I mean, presumably you could use two female, but by using only one, you're making the system simpler to study. As
Yes,
opposed, because it would seem to me you could do the or the
right,
gene editing with both, but it's just a more
right.
complicated system.
Yeah. So what you're doing here is you are essentially looking at the effects of the sperm imprinting,
Gotcha.
and
Okay.
it's actually technically easier to create a mouse with two male fathers than a mouse with two female fathers.
All right.
Uh,
Sounds like an interesting other
Yeah,
discussion, but
yeah.
okay.
Now, and there's a slide here showing an overview of taken from the paper what the researchers did, and it's actually a very complicated
It
procedure,
sounds like it.
right? So what they started with is an egg, a mouse egg cell, and they removed the nucleus. So this is called an enucleated egg,
Hmm.
and this is actually very similar to what happens during cloning, where you start with an egg cell, you remove the nucleus, and then what you do is you take the nucleus from another cell and you implant it into that enucleated
Hmm.
egg, and that creates what's called a clonal zygote. So a zygote would be the egg that's been fertilized by the sperm. You now have two sets of genetic material, one from the mother, one from the father. In a clonal zygote, you're getting all of the genetic material from that cell that you're cloning,
Hmm.
right? But you still, in effect, have a zygote. It's just that one is formed through
Hmm.
fertilization, one is formed through the cloning procedure.
Okay.
So it's referred to as a clonal zygote. So what they did is they created an enucleated egg, and instead of taking a nucleus from a cell that has, the
Hmm.
full complement of genetic material, they used the sperm cell, and so
Okay.
now you have an egg cell that has half of the genetic material, and this is called a haploid zygote, or another name because it's coming from the sperm. It's called an androgenic
Okay.
zygote, right? And there are techniques that you can use, which was surprising to me, so that you can actually get an androgenic zygote to develop into the early stages of an embryo.
That is interesting.
And
Yeah.
so they were able to then take those embryonic stem cells that again were androgenic, and then they can now do gene editing on them to disable systematically the genes that they wanted to disable to see what
Hmm.
impact that would have on embryonic development.
So if I remember correctly, you mentioned having two fathers and no mother. So far, what I'm getting you're describing is there's a single sperm cell, so there's only one
Right. We're getting
getting there. Okay, we're
we're
still
getting
working. All right.
yeah,
Okay.
yes. This is a complicated procedure, right? And so now, but now you can do the gene editing
Hmm.
on these androgenic, embryonic stem cells. So then the next thing you do now is you take another egg cell and you enucleate it,
Okay.
and then you can take a sperm cell simultaneously with that embryonic stem cell and
Okay.
inject it into that enucleated egg. So now you've got the full set of genetic material, but it's coming from two separate sperm, or in effect, two separate fathers. If this,
So presumably, what you're doing in that first enucleated cell that you're doing is you're introducing things that not allow it to act like a female
right,
egg, but it
right,
allows it so that when a new sperm cell comes in,
right,
it can combine and become the full complement of
right.
genetic material.
So
Okay.
and so then what you have is that one sperm cell is properly imprinted.
Hmm.
The other sperm cell, you're manipulating the imprinting.
Right.
And so that now allows you to assess the effects. Unfortunately, those clonal zygotes will not really develop much beyond the first few stages of cell division. You can't get a viable embryo.
Okay.
So what do? They do another really interesting trick where you can take an embryo at the 2-cell stage, and by by using electricity, you can actually get the cells to fuse.
Hmm.
Now you wind up with a clonal zygote that has four times the genetic
Okay.
material. This is called a tetraploid zygote. And those will actually develop into embryos. They're non-viable, but what's called the trophoblast, which is the part of the embryo that actually will form the placenta, is viable. The inner cell mass, which actually forms the embryo proper, dies off.
Okay.
So they create this tetraploid zygote, get it to develop into this rudimentary embryo. Then they can implant the stem cells that they've created through gene editing into this. And now you've got a viable embryo that you can implant in a surrogate. And they saw about 12% giving live births.
Wow.
And then a few of them actually made it to adulthood. And this is the next slide from the paper where it just shows, again, an overview of what they did. But now you can start playing around with what happens if we only disable, of these 20 genes that we think are critical for embryonic development. What happens if we disable 7 of them? What happens if we disable 14 of them? And you can start playing around to see what does it take to get normal embryonic development to the point where that mouse would actually go to adulthood. So that what they've created here is really a model now that allows them to assess the effects of genomic imprinting. And the next step, apart from doing additional gene editing experiments, would be to actually try this now in non-human primates like monkeys, like macaques, for example, which now moves you close to at least the human animal.
Yes.
So the idea is that this could be, again, a really valuable tool to develop fundamental understanding. So the point behind this work, even though it really seems quite frightening and a little bit bizarre, actually is noble, right? They're trying to understand basic biology that could have wide-ranging implications in terms of reproductive health and even in terms of animal cloning and stem cell biology. So really important work that on the surface seems to raise all kinds of ethical problems, but as we understand it, there's really not an ethical concern to be had here. It's just a research tool involving mice or eventually involving monkeys.
Well, can you kind of connect some of the dots? Because in principle, I could see some of that, but since you're a little bit deeper into understanding the connection, how does this play out? I could just in an initial picture here, it's like there's quite a waste of life. I mean, you say doing all of this, you get 12% survival rate, which means to do many studies, there's a whole lot more mice that die than not, type.
Yeah.
So what are if you put as a bottom line, okay, this needs to help human flourishing in some fashion. Practically, what does that look like? What are some of the things that you see people working towards?
Yeah, well, I mean, for example, anything you understand about basic biology is going to be useful in terms of developing a better way to promote human health, right? Particularly if there are diseases that are known to be diseases that arise from failure or improper genomic imprinting. So you're developing that basic science knowledge that could very well be translated into some kind of therapeutic application.
Okay.
But one of the issues with getting stem cells to properly develop into different cell types very well could be related to imprinting effects, right? And so this allows you to maybe develop more robust stem cell lines that could be used for therapeutic use. And here I'm not necessarily talking about embryonic stem cell lines, but adult stem cell lines or induced pluripotent stem cell lines.
So this is the sort of stuff where, and I'm drawing a blank on some of the diseases you might be thinking of, but where, if I've got some sort of genetic disease or disease where having healthy cells, if you could take my cells, make them into whatever these cells are, in principle, you could cure my liver or whatever the problem that I would have, because now you can generate, or we have the capacity to do things that our bodies will use these to regenerate whatever it was that was damaged. That's the sort of idea behind this.
Yeah.
Okay.
And then with animal cloning, which factors into a lot of biotechnology applications, this again helps to develop a more robust cloning process, because part of what has to happen during the cloning process is resetting the genome of the adult cell to an embryonic state. And so that's not necessarily an easy thing to do, but some of that reset has to involve getting proper genomic imprinting.
Mhm.
So by understanding it, there's other applications that are going to have real world use that could promote human flourishing. So there are very good reasons to do this. And from a theological standpoint, we have to keep in mind that we are made in God's image, which means we've been granted dominion over the creation. And we're to exercise that rulership over the creation in a way that promotes human flourishing, respects human life, that respects animal life, helps to take care of the environment. And so we have been given the God-granted authority to do these kinds of experiments. This is part of exercising dominion, particularly if the eye is towards, again, creating knowledge that could help, at least in principle, human flourishing. So there are very good reasons why we would want to support this kind of work as Christians.
So, again, just questions that come to my mind as I'm thinking about this. We've had discussions about what are the consequences of the fall. Going back in Genesis, there. So we're given dominion. I look at the effect of the curse on Adam was, all the stuff I've given you to do is going to be harder to do. And, we've had these discussions. Did creation change or did humanity change? And at least there's at least a reasonable component of that, is that the consequences Adam is going to face is because he will no longer do what he's been given to do well.
Right.
Is this... it seems like this is ripe for let's not do it well. Because there are things I'm more and more aware that a lot of times, these drugs that we have that provide great health to people. Don't get me wrong. I'm not poo-pooing the drugs here, but it's not doing what was originally there. And so in some sense, you could argue it's masking another problem that's there. So you're treating a symptom instead of a disease. It seems like this has a lot of ability to do that, so I guess I'm kind of just throwing that out for your thoughts and discussion there.
Yeah, well, I mean, any technology can be misused.
Right.
And that would be very much the case for what's being developed here, or you could envision the misuse. But that's right now not even on the radar screen of anybody involved directly in this kind of work. Now, there are other examples of biotechnology where the impact of human sin and the fact that we are unwise, or that we will do things that maybe harm humans as opposed to promote human flourishing, particularly those humans that are marginalized, are much more prominent. This is just simply one of those instances where it's not. And in fact, you could argue these kinds of experimental models allow us to gain understanding of embryonic development that could apply to humans without doing any kind of research on human embryos.
Yeah.
So we could actually see this as a good thing.
And it also, just even in my mind, it's basically any tool you use to develop to accomplish good, the power of the tool could equally be used for bad.
Right.
If you adopt an approach of, well, we're just never going to do anything that might be used for bad, we're also never going to do any good. But it just seems that it's increasingly important, or increasingly apparent to me, that if we're going to continue to develop these tools, how we decide to live as a culture is going to be really, really important.
Well, one of the dilemmas, and if our friend Ken Samples was here, he would point this out. One of the dilemmas of human nature is that we are good and we can do incredible good, and that we are wretched and we can do incredible evil.
Right.
And I think it's a mistake to think that somebody who is a secular scientist or biotechnologist is necessarily going to only be in that category of being wretched or evil, that they are capable of doing real good, right? And a lot of times I actually see that as an inroad to actually making a case for the Christian faith, right? Because they are, on one hand, trying to do something noble and trying to do something good. And ironically, a lot of times with emerging biotechnology, you see both the good and the wretched at play at the same time. So you'll have almost this inconsistency where scientists will want to develop embryonic stem cell technology because they see it as a way to treat horrific diseases that people are suffering from. That's a good thing.
hmm
But then at the same time, they're willing to experiment and manipulate and destroy human embryos to achieve that, where the wretchedness comes in. And so there's an inconsistency that I think we could exploit as a way to say, wait a minute, have you really thought that all the good you're trying to do is actually being undone by the evil that you're doing?
Right.
And
Yes.
that then opens up, I think, an opportunity to talk about human nature from a biblical perspective, that we
hmm
are image bearers and we're capable of doing good, but we're also damaged by the fall. And because of that, we can do horrific
Yes.
things in the name of good sometimes.
Well, and to your point, if as Christians we're not engaged in that, yeah, I mean, I've had this thought with artificial intelligence. I think
Mm,
in my ideal world, we might just say, wait a second, let's just put a pause on this.
right.
But, for instance, if the US decides to put a pause on it, nothing says China or other world leaders aren't going
Yeah.
to. And so now who's going to be deciding what's happening most of the time? Well, the more powerful are going to be. And so it
Yeah.
seems like as Christians, it's important that maybe not that I understand all this, but I support the people who do understand it and want to, or those Christians who do want to understand it, engage it. Because
Yeah.
I could see where you'd get a lot of pushback from saying, hey, this is a good thing, here's what's going on, because people would just say, oh, you're just supporting some sort of evil technology. It's like, well, no, you're trying to take the Christian worldview, understand what the science is, and then go and engage in what could be a very
Yeah.
hostile culture. It's kind of hard to engage that hostile culture when you're getting hit from behind by the people who you're trying to advance the same message. So,
Yeah. Yeah. Well, but this is again all the more reason why we, even though it's hard work, we really have almost an obligation to do that.
yes.
Because if we don't, we're failing the Christian mission, and we're failing our culture who is apart from Christ,
hmm
right? If we're not willing to be that voice for the Christian worldview, and through that process help people to see the good that is represented by Christianity, we really are failing in our responsibility.
hmm
God never called us to ministry saying this is going to be easy. So
Yes.
why should we expect this to be anything other than difficult?
Well, so how would you encourage? I mean, I get the benefit. I like science. I'm
Right.
not particularly interested in biochemistry, but I love talking with you just in seeing some of the fascinating stuff and learning what's going on. Uh, but so I guess my question is, how do you help the person in the pew who,
Yeah.
by and large, they're just raising their kids, trying, I mean,
Yep.
you knew you as well as I know that takes an enormous amount of time, and
Yeah.
there's a lot of things to work on there. I can't really tell a Christian, the average Christian
Yeah.
in the pew that, okay, you need to go out and learn about this biotechnology.
Yeah.
But what do you want to tell them
Yeah.
in
Well,
doing that?
what I would say is maybe you can't develop kind of a global comprehensive understanding of the biotechnology. I mean, I'm a life scientist and I have to spend a significant amount of time
Right.
going through the paper to try to understand what the scientists did and what their motivation was, even with the benefit of having all these science news articles available to me. It's not an easy thing, but I would say find that area that really interests you and
hmm
just become an expert in one area, right?
Okay.
Or at least do reading and dig deeper in that one area. And, we also live in a time where there's incredible resources available to average people through all the programming that's available on YouTube, including this programming, organizations like Reasons to Believe. Those are places where I think people can go. And I think if you try to eat the elephant all at once, you're going to wind up
hmm
with indigestion. But if eat the elephant one bite at a time and just maybe say, all I'm going to do is eat, the left leg, the
hmm
left, foreleg of the elephant, that would be good enough, because at least you're able to then contribute to that particular conversation.
Yes.
And when you spend that effort learning about one area, oftentimes you develop a skill set that allows you to more seamlessly go to other areas, or what you learn there can be applicable into other areas. So over time, you can develop a pretty decent expertise, at least enough to be able to be a positive conversationalist with regard to our culture.
Well, it also, I'm just listening to your answer there, and it also seems like there's a part of that, and this may be stretching the scriptural analogy a little bit, but we're a body, and the body has different parts. So
Yeah.
it may well be that you're obviously scientists, biochemists, and engage in this field. Um, if I'm not scientifically interested, I can at least see, hey, God's gifted you to go do this.
Yeah.
How can I support you? Whether I understand everything you're saying, support
Yeah.
the mission you're doing, because
Yeah.
we're all doing the same mission.
Yeah.
But there is a trick, there is a challenge in that, because a lot of the times the things you're doing, I may not be able to do because of some weaknesses I have or differences of thoughts I have. And you're playing in an arena that I think is pretty dangerous.
Yeah.
And so
Yep.
there's more to that than just saying, oh, well,
Yeah.
you're a hand, go
Yeah.
be a hand. I have to understand a lot
Yeah.
more about that.
And something, I'm in full agreement with you, but one point of caution is we don't also want to just simply elevate certain people to be the voice of the Christian faith.
No, that's a great point.
Because some of these technologies are so complex scientifically. The ethical issues are complex. The theological issues are complex. And so I may develop a perspective that's well thought out that doesn't necessarily represent the Christian perspective, but a Christian perspective. So you want to make sure that as you are elevating people to represent the faith, that you're elevating different voices, and you're really encouraging those voices to be in dialogue with one another and to be in dialogue with the church at large. So in other words, it's going to take a community of effort in order to really have an effective Christian voice. But even if we have people with differing viewpoints, for those differing viewpoints to engage our culture well is still representing the Christian faith well, right? And I think we all would agree on certain core principles, ethically and theologically. How we cash them out may be different, right?
Yeah. I'll make a passing comment. I'll let you choose whether we go explore it or more. But I thought COVID was a great example of how the church didn't do that well.
Yeah.
Because it was kind of like, what's the church's view? What are we going to do? And everybody had to align with that. And I think there are people who needed to be more cautious. There are people who needed to be more. It seemed like we took a little bit. There's a one way a Christian can do this, and that seemed to cause a lot of tension.
Yeah, I would agree with you. It's probably not worth going down that path, but that's a great example of where, regardless of the position you took, and I was an elder at our church during COVID, and you could not make a right decision, right? No matter what you decided, you could not make a right decision, because any decision would divide the church.
Right.
It was just a no-win situation, and it's because people that were, thought the church ought to do one thing would look at us, would look almost with derision at people that thought the church ought to be doing something else. Yes. There was no place for dialogue. There was no place for respect towards one another. And we want to avoid that happening again. But that's a beautiful example of where we have an obligation to be open-minded as we engage these issues.
Right. Well, and it's like there's you need to be open-minded, but the boundaries can be very hard at times.
Yes.
We tend to shrink the boundaries too much or be so open-minded there are none. And
that
having open-minded but hard boundaries, that's not a popular place to live. So Any final comments?
No.
This is a fascinating discussion.
Yeah, thanks, Jeff. Yeah, I've had a good time. So Yeah, all yours.
So mine's in some sense a little more mundane because it's looking. There's just this idea of is there life out in the universe, and
Mm.
I kind of half jokingly and not entirely jokingly think that this is probably something Adam and Eve were arguing about: is there life out in the universe? Just because it's such a fascinating question, if you will.
Yeah, yeah.
And what's kind of fun about it now is that we've got scientific tools that at least allow us to explore and address the question rather than just thinking about it. And
Right.
so there are actually a number of projects that have been proposed. Some have come and gone. I think there was a terrestrial planetary finder that was one of the missions that NASA had going for a while and has been at least sidelined or not prominently. But so there's two of them I know that are out there: the Habitable Worlds Observatory and the Large Interferometer for Exoplanets. So it's HWO and LIFE are the two acronyms for it. But there's this very real possibility that we will develop these probably multi-billion dollar instruments, put them up in space, do great technically challenging work, do it well, and observe. I think they're both slated to try and observe and characterize, a few dozen to, somewhere between 25 to 100 different planets,
Mm.
and actually get information about the planet more than just its size. But there's a very real possibility they could get up there, do all of that, and find there's no signature of life out there. And so the question that flows out of that is, okay, so now what? Is this worth doing? What
Yeah.
do we learn? How do we learn? And that's kind of the
Well, and 25 to 100 isn't necessarily the largest sample when you're dealing with the universe.
no, very fair point. And that's part of this challenge is that we found a whole wealth of planets outside our solar system. So back in the 90s, when we first started discovering planets outside our solar system, I think the number's grown up into the 9,000 range at this point. So the technology to find planets is just tremendous. And you're routinely, it's kind of tapered off for a while, but for a decade or so, you're hearing routine, oh, here's another habitable planet. And if they were careful, it's more, here's another potentially habitable planet. Because what
Mm.
often got missed in that is habitable meant, well, we can tell where the planet orbits, and therefore it might be in a place where it could have liquid water. And one of the points that I've tried to emphasize in that is, or as I talk about this, is that the reality of what we actually know is that we have very little idea to what these planets actually look like. We know they're
Mm.
spherical just because there's gravity tells us that. We know what kind of star they orbit. We know their physical size often, maybe their mass, those sorts of things.
Do we have a good understanding of their distance to their star?
Yeah, usually we get good if how far away the star is, what kind of star it
Mm.
is, how far it orbits, what kind of orbit. Those are the sorts of
Yeah.
information we have.
Which is remarkable to think
Oh,
that we could extract that kind of information,
oh,
I think.
absolutely. No, it's there could be a part where it sounds like I'm playing down or under. The technological sophistication to be able to accomplish that is phenomenal. But it doesn't answer the question we really want: is there life out there? Is there life on this planet? And so if we said, all right, we know there's a planet around this star, could we ask the question, is there life on that planet? And the answer is we don't have the capacity to do that. To determine whether a planet is actually habitable, I came up with an analogy. You put a 100-watt light bulb a mile or two away, and you have people walk in front of the light bulb, and you say, "All right, I want you to build me an NBA caliber team." Not going to have a lot of success, most likely, simply because it's just that hard of a task. Well,
Yeah.
we don't know whether there's liquid water on a planet. We don't know what's in its atmosphere a lot of the time, or the planets that we do know are so large we know there's not life there. And so
Mm.
you kind of get this mixed message of, oh, we know a whole lot about these planets, and there's all these habitable planets, and we've got a lot of accomplishment and achievement, but we aren't really able to address that question. And that's kind of what this paper is getting at, is recognizing, we could build these instruments, they could be phenomenally successful in accomplishing everything we've asked, and they come back with 25, 50, 100 planets where we have no measurement that indicates any sort of life is there. And so what what conclusions can we draw about that? Can we actually say there's no life in the universe? Can we say there is? These are the things they were wrestling with. And what was interesting is that they found that, or the bottom line they walked away with is that if we can get really good observations and perfect observations, and that there's no uncertainty, there's no error, so living in a little bit of a scientific fantasy world, but with 20, I think they came up with 40 to 80 perfect planets, they can actually constrain the fraction. If we were to be able to make measurements on, is this a habitable biosphere? Is there life on this planet? If we were to able to get those measurements and they all came out no, then with 40 of those planets, we could say that the fraction is less than 20%. So it seems like, wow, that's not much.
Yeah.
But that's a pretty remarkable statement. We can say, based on our measurements here, where we get all this information, a relatively small sample, we can make a general statement that there are less than 20% of the planets in our galaxy could have life on them. That's a pretty big accomplishment. And if we can get 80 of those, you can get it down to about 10%. And so I think that's pretty cool. The problem, one of the challenges is that this increases with uncertainty in your measurements. So you've got to be able to say, no, there's no life there, which, I happened to just read another paper that was talking about whether Titan, a moon of Saturn, could host life because it's got a lot of hydrocarbons. And the bottom line of the paper was, if there was life there, just given the amount of organics delivered to a certain place, that Titan could host a few kilograms of life. So being able to say there's no life on a planet down to a few kilograms, that's a tall order. And so you could see some of the challenges that arise in this. And so nonetheless, I think that's fascinating. But to me, this raises two questions as a Christian as we're engaging in apologetic issues and trying to engage people with the gospel about this. Because one of the big questions I have as a Christian is, what if we find life out there? And what really got me thinking deeply about that was not that I think we've found signs of life or we're going to find signs of life. It's not that the science is leading that way. But the way I'd often heard arguments we talk about, the universe is so designed, the earth is so designed, all of these preachers need to be met. You can put probabilities on that. And for whatever reason, I walked away from that thinking, okay, this is such a rare event that in the universe, you only expect it to happen once. And we are where that is, which leaves this implication that if we find life on another planet, okay, if Christianity and all the calculations you say says that it only happens once and we're here, and then we find life over here, that says, ooh, your model is incorrect. And it's not just a scientific model, it's a Christian scientific model, if we will. And so if our model is correct, that means Christianity is incorrect. And so this is kind of what I was trying to think through. Is that the right way to think about it? And so that was my question. So I can make all of the calculations I want and say there's no life out there. I don't expect it to find it anywhere except here on Earth. And the moment we find it as a Christian, I have to say, okay, what do I do with that? Because all my probabilities go out the window the moment I've actually detected something. And so it got me thinking, okay, how do I, as a Christian, how do I make that argument, recognizing that theologically speaking, whether there's life out there is not a settled question. You can just read scripture and it's not clear whether God created life here, whether God created life multiple places. I could make an argument both ways just based on what I know scripture and what we find just looking pretty cursorily here at the earth. And so if the argument is life, all the requirements for life is so rare, the only place we expect them to be met is one place, we're on that place, therefore this is the only place, I am setting people up to be skeptical of Christianity. And what had occurred to me is that it's not that given all of the probabilities, we only expect it once. It's given all the probabilities, we don't expect it at all. And apart from God's work to prepare Earth for life, we wouldn't expect life here. That's your Origin of Life book. You talk about how Genesis 1:2. In the beginning, God created heaven and the earth. the earth was formless and void, darkness was over the surface of the deep, spirit was hovering over the surface of the water. That in this hostile, the earth is hostile to life. It's not
Mm,
just there's no structure, it's
mm,
hostile to what God
mm,
is wanting to do with it. And then you see Genesis transforming that
mhm.
hostile, formless, void, dark water to something that's teeming with life. And so, biblically speaking, or theologically speaking, unless God prepares it, it's not going to be suitable for life.
Mhm.
So now that raises the theological question of, did God do that somewhere else?
Yeah.
And it just changes the whole flavor of the discussion.
Yeah.
So I'm going out there and I can say scientifically, hey, there are all these things that need to come together. I don't expect to see that met at all. In fact, when I look at here on Earth, I see evidence of God's signature
Mhm.
of taking this place that shouldn't have been habitable. And I just look at Mars and Venus,
Yeah.
who are very close to the Earth. And though you may not have been able to tell them apart when they first formed. Earth's the only one that has all this, and we
Mm,
see this great
mm,
symphony of orchestrated events that really looks like it's designed, it has a purpose of being here.
mm.
That is my argument for why I think God exists,
Yeah.
or why the scientific argument. It's not that
Yeah.
it's so rare I only expect it once, it's that
Right.
apart from divine intervention, I don't expect it at all.
Right.
And now the question is, when we find life out there, or if we find life out there, it's not a problem to me
Yeah.
because that's just now become a signature of, okay, God has done this over there as well. And what can we go learn about it?
Yeah. Yeah.
Curious your thoughts or how.
No, I think that's a great point. Although I could see that, that the idea that you calculate these probabilities, and your point isn't really that the only place we should find life probabilistically is here on Earth. We shouldn't find life at all,
Right.
right? That's really the probability. So to me, I think your reasoning is sound, because if there's life here and we understand it to be a creation event,
Hmm.
and we see life elsewhere, hypothetically, then it seems reasonable that we would think, in light of those probabilities, that that's probably a creation event too.
Right.
Yeah. So yeah, I think that's a really good way of framing it. Where the probabilities are helpful, I think, to highlight really the uniqueness of the Earth, and
Hmm.
really the
Yes.
the 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 fact that there shouldn't be life here at all. I think that's where the probabilities are helpful. But I think the positive argument, which I always prefer apologetically, is look at all these things that had to happen.
Hmm.
All these coincidences that stack up. Either we're incredibly lucky, and we've won the lottery over and over and over again, or there's a mind behind it.
Right. Well, and it also raises this fascinating possibility of, might God have done it somewhere else?
Right.
And the other part that I really enjoy, um, you know, it, Christians have wrongfully, but often portrayed as kind of, oh, the Bible says it, therefore you don't think about it anymore. Well, as I'm thinking about this, okay, so if life is out there somewhere, now that's theologically a more challenging question, or at least it
Right.
was for me when it came up, because there's something about being unique that makes things special. If I'm no longer unique, am I
Yeah.
special? And
Yeah.
I've realized that having kids, I love all of my kids. The first
Yeah.
one, there's something new about that, just because
Right.
it's new. But just because I have more kids doesn't make the first one any less special.
Right.
They're special because they're my kids, and so
Right.
so this now gets me thinking. Okay, if God created life somewhere else,
Right.
it seems like a lot of people say, "Well, is it bacterial life or is it advanced life?" I'm like, it really kind of doesn't matter.
Yeah.
To me, God, the best way to explain that at this point,
Right.
given what we've seen on Earth, is that God created it there.
Right.
And so now you have this question: what if He created other creatures like
Yeah.
humanity? Are they
Yeah.
fallen? Are they not?
Yeah.
And what I found humbling and incredibly encouraging at the same time is that Christians have been thinking about this forever.
Yeah.
I mean, we have this perception that Christians have thought, oh,
Yeah.
Earth is the only place that hosts life, and if we find life, that means Christianity is wrong. It's like, well, before science even was born, Christians had developed a very robust theology about this.
Mhm.
So it's not even like I had to come up with new ways of thinking. It's like
Yeah.
all I just had to do was read theology that people have thought centuries
Mm.
that I specifically, but maybe
Yeah.
even millennia before
Yeah.
science had even come to play at the table.
Yeah. Well, I mean, from my perspective, I like to view God as both a designer and an artist, right?
Right.
An engineer and an artist, because a designer really implies, I think, both. And so if part of God's artistry is just this I wouldn't say compulsion to create, that seems to be wrong to say that God is compelled to do
Right.
something, but that it's God's very nature as a creator to create,
Yes.
right? And that creation is for his enjoyment and for our enjoyment.
Hmm.
But, if God is a creator, then why would you expect God to stop here on earth? Right? That would,
Yes.
be my expectation is I wouldn't be surprised if there was life out there. And, I'm a biochemist, so I'm going to be careful about treading into theological area or in arenas, but just because we're made in God's image and that we're made to have a special relationship with God and we're the crown of creation doesn't mean that God doesn't necessarily have a relationship with other features of creation, with animals
Right.
necessarily,
Yeah.
right? Or that God doesn't love and prize other aspects of the creation.
Hmm.
It's just that we have a unique status as image bearers. And so you could even have people and, intelligent beings in other, parts of the universe that wouldn't be image bearers necessarily. And it doesn't mean that they weren't important to God or God doesn't love them in that way. I
Right.
mean, we take the view that Neanderthals lacked the image of God, but it doesn't
Hmm.
mean that they were not necessarily fascinating creatures that deserve
Yes.
some measure of respect, right?
Right.
Or they wouldn't be the object of God's love in some way.
Well, and I was just reading this morning about, about storing up treasure and God saying, look at the sparrows.
Yeah.
I care for them.
Yeah.
I mean,
Yeah,
it's
that's a
not
good
like
point.
it's even hard to get that out of scripture. I mean,
Yeah.
there are places where it's explicitly said. And there's I haven't figured out how to articulate this well yet, but I'm just increasingly coming to if you read scripture and all of what it has to say, it explains it gives a very good if I'll say it this way. If you read scripture and ask what kind of world would you expect us to live in, and then you go look at the world, it matches very well.
Mhm.
I mean, because just even to your point, it's not like I have to imagine, would God have other creatures that he might love or care for? Well, he created the angelic realm.
Yeah. Yeah.
It tells us the stuff that allows us to think these thoughts
Yeah.
and to think them well. So
Yeah.
I find an abundance in scripture. You're talking about God compelling. I think it overflows out of his nature
Yeah.
that he does it. And so
Yeah.
I really, I like thinking about things this way. And it relates to our previous discussion in that it's not that I necessarily need everybody out there to be thinking this way, but
Yeah.
recognize I think God's put people in the church who are,
Mhm.
why is that? How would that work? Kind
Yeah.
of being encouraged, inquisitive, and that God has a purpose in that.
Right.
And he's put other people, it's like, let's keep things moving in a certain way
Right.
in order. I mean, I'm married to an order and routine person, and I'm more ordered but spontaneous, if that makes
Mm.
sense. And so God has put us together and allows us to, as we work together and utilize that, we're able to do far more
Mm.
than either of us could alone, And
Mhm.
so l- learning how to appreciate the grandeur of creation instead of trying to either make the walls so big that there is no
Mm.
boundary. There are boundaries, but also, or that we also need to, if we're within good theological standing, don't restrict what Christians in there can do as long
Yeah.
as they're following and serving God. So,
Yeah. 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 Good point.
so
Yeah.
well, this has been a fascinating.
Yeah. It's been fun,
I
Jeff.
am curious to see how this plays out, and a little bit terrified at the same time. Well, thank you for joining us on our Star Cells and God discussion today. I want to encourage you in the discussion below. Put your comments and join and participate with us. Remember to like this video, to subscribe for more content. We have new episodes of Star Cells and God released each Wednesday. They're available here on YouTube and on your favorite podcast app. Share this video with a friend. Have a great discussion about it. And remember, the more we know about science, the more reasons we have to believe.